Hey Chad, what are we going to be learning about today?
We are going to be learning about how to take limits of rational functions and solving them.
So I guess we could title this presentation Finding Limits of Rational Functions.
By Chad Kuchermeister and Joe Gibson, 11th, 12th period.
AP Calculus. Let's go.
Well, I think the first thing we should define is what is a limit.
Alright, so can you tell me what a limit is, Chad?
A limit is a height in general terms, or also known as a y-value in an equation.
Okay.
So let's take this limit that we read as the limit as x approaches c of the function f of x equals L.
Okay.
This means that given real numbers c and L, if the value of f of x of a function f approaches or equals L as the values of x approach c, we can say that the limit of f of x as x approaches c is L.
Now, can you put that in a little bit more simple terms, Chad?
Sure. In English, we can say that the function is approaching c, the limit equals L.
Okay, that makes sense. So, if I wanted to go and solve one of these limits, I'm a simple kind of guy, what would be the easiest way to do that?
Your first and easiest step always when solving limits of rational functions is a method called direct substitution, which is pretty much the easy way. So, let's take this limit, the limit as x approaches c of 2x plus 1. Alright? Now, your first step in solving a limit is always direct substitution. That means taking the value that x approaches and putting that in for x in the equation. Therefore, this example would look like this basic problem.
So you're going to plug in 3 for x. So it's probably going to come out to something along the lines of 2 times 3 plus 1?
Yes, I'm going to take this 3 right here and plug it into the x right here. So it's going to be 2 times 3, which is obviously 6, plus 1. And that's going to get me an answer of 7.
Nice. I like this method.
And in this case, you're done.
Great. So that's probably the only thing we need to know, right? I mean, that's going to give us the answer every time.
Well, unfortunately, I wish it was that easy. But there's also things that we got to learn about limits that can cause problems. The most important one is what we like to call the indeterminate form, also known as the 0 over 0 case.
Okay.
Okay? Now, most of the time when you're solving rational functions with limits, you're going to get an answer of 0 over 0, which obviously is 0, when direct substitution is used. This is called the indeterminate form. It is called the indeterminate form because we're not sure if 0 is the answer. Unfortunately, as easy as this looks, we usually cannot keep it like this because it's usually not the correct answer when dealing with rational functions. So, there are 3 solutions to this problem. One, and the easiest, is looking at the graph from a calculator, multiplying by the conjugate, or factoring.
Alright, I think we can handle these.
Yeah,
let's start by looking at the calculator.
Well, we're going to start by using the conjugate here. Okay? Now, we will get to a calculator part later.
That's right.
Alright, so let's consider this limit. The limit as x approaches 0, x plus 4 minus 2. The first thing I would do, and I hope you would do, would put 0 in for x, and you would get 2 minus 2 on the top, and then 5 times 0, which is obviously 0.
So I want to say that 0 is the answer, but it's probably not due to this indeterminate form, right?
You would think that 0 is the answer, but it's not. So now let's go to our calculators and look at the graph of this function.
Okay.
Okay? The graph to the left here is the function from the previous slide. The limit as x approaches 0 as of the square root of x plus 4 minus 2 over 5x. As you can see, the graph shows that as x approaches 0, the y-value is not 0, but rather 0.05 or 1/20th.
Now, how is that possible, Chad? If direct substitution gives us 0, why does the graph do this?
This is what the indeterminate form is about. This is what the indeterminate form says. It says, don't think direct substitution is your easiest friend. Now, this is a side note for later that we will go to in our next methods, but this is actually another method of determining a limit, which is simply looking at a calculator. But for this example, let's pretend that this is one of Mr. Van Arnham's non-calculator tests, and you wouldn't be able to see this or know this.
My favorite tests.
Okay, so we're going to take that limit, and we're going to multiply by the conjugate.
Okay, so the conjugate is just simply a form of 1. So we're going to take, the square root of x plus 4 plus 2, and put that over the same thing, the square root of x plus 4 plus 2. that should give us something a little better to work with, right?
Exactly. When you multiply by the conjugate, you're simply multiplying by a form of 1. So, we're going to take that multiplied by the conjugate. The square roots here are going to cancel out, and so will the 2's. So you're going to get 1 over 5 times the square root of x plus 4 plus 2.
So with this new, more simple form, I suppose, of this limit, would you say that we can go back to direct substitution? Would it give us a different answer this time?
Absolutely. This is now when we can use direct substitution by plugging in 0 for x. So therefore you would get an answer of 1/20th or 0.05, which is, if we go back to the calculator, that's what it gave us.
That's exactly what showed up on the graph. That's really cool.
Right, exactly. Now, this is what most of the time you're going to be doing with limits here. You're going to be taking an equation and by multiplying by the conjugate or doing something else that we'll get to later to make it into a form that we can use direct substitution. Remember, direct substitution is always our friend. We like direct substitution.
I like direct substitution.
Okay. Okay, so we're going to take this other example now and apply our easy method of using our calculator. Alright, we're going to consider this limit as x approaches 0 of sine x over x.
So our first step would definitely be to try direct substitution. That would give us 0 over 0.
Right, in this case, the sine of 0 is 0, and x is obviously 0.
Now, I want to say that 0 is the answer, but based on what we just did, I have a feeling that it's not.
Alright, well, we're going to pretend that this is a calculator portion of Mr. V's test, and we can use our calculator. So, here's our graph, right?
Alright.
So, as you can see here, x is 0. The function is definitely not 0. Alright, we can say now that as x approaches 0 from either side,
it goes to 1.
It's going to go 1. So therefore, there's your answer. The limit as x approaches 0 of sine x over x is 1.
Wow, that is much easier than trying to find that conjugate.
Yes, exactly. And which, if you have a calculator, that's most of the time what you want to do. If you use direct substitution, you get 0.
Okay. Now, we did have one more method to talk about, didn't we, Chad?
Right. And I mentioned it was factoring.
Okay.
Factoring is obviously something that we've known since Algebra 1, and is something that can really help us out here with rational functions and limits.
So, say we had the limit as x approaches negative 3, x plus 3 over x cubed plus 27. So the first thing that we're going to try is direct substitution, and I think that is going to give us 0 over 0. Which,
yes,
again, is another example of the indeterminate case.
Yes, and I would hope that by now you can trust me and say, when I say that 0 is not the right answer.
Alright, so if we've tried conjugating and we've looked at the calculator, how are we going to factor this?
Well, there is no reason to multiply by conjugate because there's no radicals to get rid of.
Okay.
You only want to do you only want to do conjugate when you have radicals, that because multiplying by the former one will cancel out the radicals.
Mm-hmm.
So in this case, let's see if we can factor something.
Okay. Something funny is going on in the denominator of that fraction. I kind of recognize something, do you?
Does the sum of cubes ring a bell?
Ah, yes, it does.
Okay, if you look at the denominator, you can obviously see that it's the sum of cubes. Here's the formula for that. The denominator is in the form of a cubed plus b cubed. So, we can easily, using this formula, make the limit like so. So, now, we're almost ready.
In this form, do you think we're ready to use direct substitution? I mean, it looks pretty clean and simplified to me.
We're pretty close, but unfortunately, you're still going to get a 0 over 0 case. If you plug in negative 3 here, you can get negative 3 plus 3, which is 0, and then you're going to get negative 3 plus 3, which is 0, and then 0 times anything is 0, so you're still going to get 0 over 0.
Alright, so do you think there's anything we can remove from this equation? Maybe that x plus 3, we can get rid of that?
Well, yeah, let's take a trip back to geometry, where we had our favorite friend, Mrs. Warren, who always sung the tone of Bing Bing. We can cancel these x plus 3 values out because there's no plus or subtraction sign, so these x plus 3's easily cancel out. In the words of Mrs. Warren, Bing Bing. This would now leave us with the limit as x approaches negative 3 of 1 over x squared minus 3x plus 9.
Alright, I feel much more comfortable using direct substitution with this now, so let's plug that in.
And that's exactly what you want to do, and you're going to get an answer of 1/27.
Nice.
Okay, so those are the basics of rational functions and limits.
So if we wanted to go over everything again, what is the purpose of a limit? What is a limit?
Alright, remember, a limit is a y value you're trying to find in a problem.
And when we're trying to find this, our first step is always direct substitution. Right?
Always, no matter what. Direct substitution is always your first go-to. It is your friend.
So if the answer is not 0 over 0, then we're done. That's it. We can move on.
If you're positive you did it right, and it's not 0 over 0, you can be pretty confident in saying that's your answer.
Okay, now say we do come across the indeterminate case. What do we do? What are we looking at the equation? Can we see if there's any way we can simplify it?
Yeah. If you find yourself looking at the indeterminate case, look at the equation and see if there's any way you can simplify it, such as maybe multiplying by a conjugate to get rid of radicals, or factoring to get into a better form that you can use direct substitution and you won't get a 0 over 0 case.
Now, in a perfect world, getting 0 by direct substitution would be the right answer. But you've always got to make sure that 0 is the right answer.
Exactly. You could get 0 when you do direct substitution. It could be right.
But you always have to look at the graph first, right?
I would always look at the graph to verify if you can. And if you can't, make sure there's nothing you can do to simplify that function.
Yeah, if you have no calculator on you, make sure you try multiplying by the conjugate or factoring first to see if you still get 0.
Absolutely. That is exactly what you want to do.
Well, Chad, I feel like I know a lot more about this topic. I'm really comfortable with limits now.
I'm glad I could help.
All right. Thanks, Chad.
Absolutely, Joe.